Now this is a question based on dimensional analysis. You should be able to visualize because here there are so many powers which are unknown, and this can be done very easily with the help of dimensions. If you look up t, the expression t is proportional to t is equal to some dimensionless constant s to the power of alpha, a to the power beta, rho to the power gamma, and r to the power delta. Then using dimensional analysis, you can see s is mt minus 2, a is L2, this is ml minus 3, and r is again L to the power delta. So the easiest thing is, let me compare the dimension of m on both the sides. So this is alpha, and this side it is plus gamma, and left hand side it is 0. This means alpha is equal to minus gamma. And if you just see, it is only the first choice, alpha plus gamma is 0, and in all other cases, alpha plus gamma is not equal to 0. So I can straightforward mark it as 1 as the answer. Although you can look up for dimension of L also. Dimension of L on the right hand side, it is 2 beta minus 3 gamma plus delta. Now you can see there are three terms, beta, gamma, and delta. So in this particular case, the deciding thing could be alpha is equal to minus gamma, because incidentally in this case only one is the unique choice. So therefore I'll mark 1 as the correct answer. To evaluate the other things, you can just check up, put the values to cross check. Now 2 beta is minus 2, 3 gamma, gamma is minus 3 by 2, and delta is 7 by 2. So you can see minus 4 and minus 7 by 2 plus 7 by 2. This is equal to 0. So 0 is equal to 0. So the other values also satisfy this. So the correct answer is first. There is no need to worry about what is the expression. So this expression itself says that this is a question of dimensional analysis. Now, a bob of heavy mass m is suspended from a light string of length L. Bob is given a horizontal velocity v0 as shown. If the string gets slack at some point, string gets slack, making an angle theta from the horizontal, the ratio of speed v of the bob at the point P to its initial speed. Now, in this particular question, two things are most important. Number one, string slacks. String slacks means tension in the string at the point P becomes 0. That means centripetal force at point P, mv square by r, or let me say r is L, mv square by L. Centripetal force is equal to, this is mg weight, and this one is mg sine theta. So centripetal force is provided by component of weight along the string. Okay, so this was the crux. Or I can say mv square is equal to mg L sine theta. This is one of the things. Second thing is energy conservation. Now, when the mass is at the point m, it has only kinetic energy, that is half m v naught square, which gets converted into kinetic energy plus potential energy Potential energy is nothing but mgl plus mgl sine theta, because you can see this is L, this angle is theta, so this is L cos theta and this is L sine theta. So what you can see is, if you write the expression for mv square, so this is mgl sine theta 1 2 plus mgl plus mgl sine theta. So this is nothing but mgl 1 plus 3 by 2 sine theta. This is half mv naught square. And since you are interested in finding the expression for v theta, so you can just simplify. This 2 gets this side. So v theta is equal to 2g L into 2 plus 3 sine theta upon 2. So this 2 gets cancelled. Now if you under root of this, and from here your v is nothing but gl sine theta. Since you are interested in finding this ratio speed v to v theta, if you take the ratio, if you take the ratio of v by v theta, you can just get it gl sine theta divided by, this is root gl sine theta divided by root gl 2 plus 3 sine theta. So root gl gets cancelled. So this is sine theta divided by 2 plus 3 sine theta. And you can see here the choice is second is the correct answer. Is that okay? So you note, important thing is here two concepts. String slack, that means tension is 0, and centripetal force is now provided only by the component of weight along the string. And second is the energy conservation. Two concepts, but it is easy. Next, a physical quantity P is related to four observations A, B, C, D as follows. Now the percentage errors in the measurement of A, B, C, D are given, and you want to find out percentage error in P. Now you are very well aware of, when we talk about percentage error, then delta P by P is equal to 3 times delta A by A plus 2 times delta B by B plus delta C by C plus half delta D by D. Now, remember, although you can see that C root D is in the denominator, because whenever we want to find out, we always find out the maximum percentage error. Although it has not written over here, but it definitely means to find out the maximum percentage error in the quantity. So this will be 3 into 1 plus 2 into 3 plus 2 plus half into 4, and the answer goes as 3 plus 6 plus 2 plus 2. So this is 13. So the answer is 13%. So delta P by P into 100. So delta P by P, right? So everything is in percentage. This itself is the percentage error. So this is, if a percentage error is 13%. Okay. Next, 13%, that means the correct choice is the first. अब ध्यान से देखेंगे. Now sun rotates around its center once in 27 days. What will be the period of revolution of the sun, in fact, period of rotation of the sun, when sun were to expand to twice its present radius without any external influence? So this is a question where suddenly the radius of the sun doubles. That means there is no change of the mass, and there is no external influence. That means this is a question of principle of conservation of angular momentum. Now, angular momentum is nothing but I1 omega 1 is equal to I2 omega 2, or I can say I1 by T1 is equal to I2 by T2, because omega is 2 pi by T, and as we are interested in T2, so T2 is equal to I2 divided by I1 into T1. Now, as you know that moment of inertia is proportional to square of the radius and mass has not changed, therefore I can simply say that T2 is equal to R2 by R1 square into T1. Now, R2 is twice the present radius, so this R2 by R1 is 2, 2 square into T1, and this is 4 times 27, and this is 108 days. So this is a moderate question. So the correct answer is second. Okay, based on principle of conservation of angular momentum. So mass is constant and no external influence. Now, the radius of Martian orbit around Sun is about 4 times radius of orbit of Mercury. Mars is 4 times radius of Mercury. If I put it as capital R and it's a small r, right? The Martian year, let me put as capital T, is 487 days, Earth days, and it is asking you what is the length of year of Mercury. So let me put it as T. This has to find out. This question is based on Kepler's third law of planetary motion, which states that T square is proportional to R cube. So T by small t square is equal to R by small r whole cube. As we are interested in finding small t, so I can say small t by capital T or t by t is equal to R by r to the power of 3 by 2, right? So t is equal to, what is small r by capital R is 1 by 4. So this is 1 by 4 to the power 3 by 2 into capital T. And 1 by 4 to the power 3 by 2 is nothing but 1 by 4 under root is 2. So this is 1 by 2 cube. This is T by 8. And T is 687 divided by 8. And this is approximately 86 days. And since the answer nearest to 86 days is 88 Earth days, so the correct answer is 88 Earth days. So this question is based on Kepler's third law of planetary motion. Okay. Next, if we look about the question number 34, that is, a wire of resistance R is cut into 8 equal pieces. From these pieces, 2 equivalent resistance are made by adding 4 of these in parallel. Then these two sets are added in series, the net effective resistance of the combination. So if there is a wire resistance R, it is cut into 8 different pieces. So each of resistance R by 8, and 4 of these R by 8 are connected in parallel. So that will be R by 32, and another combination, another 4 by 4 are connected in parallel. So that will also be R by 32. And these two are connected in series. So the R by 32 into 2. So the correct answer will be R by 16. Look again. When R is cut into 8 equal parts, each part will have a resistance of R by 8. When 4 of these R by 8 are connected in parallel, the equivalent will be R by 8 upon 4, that is R by 32. Because two combinations were there, so we got R by 32 and R by 32. And then these are connected in series. So in series, both the resistance will add. So we get R by 16. This is a simple question. So the correct answer is R by 16. Next is a photon and an electron have the same energy E. The ratio lambda photon to lambda electron of their de Broglie wavelengths is. Now, you know that both photon and electron have got the same energy. So what is wavelength of photon? Energy of a photon E is equal to hc by lambda. Energy of a photon is hc by lambda. Hc by lambda. But when we talk about energy and de Broglie wavelength of electron, then we know that de Broglie wavelength of the electron is h by p, which is equal to h by root 2 me. Or in this particular case, from here we can have lambda is equal to hc by E. Now, as you are interested in finding lambda photon divided by lambda electron, so what we have lambda by lambda d, this is equal to hc by E divided by h divided by root 2 me. Now this h gets cancelled, and this is c upon E, and this root 2 me will go in the numerator. So this will be c into root 2m divided by E. So the correct answer is first. Okay. Next is a sphere of radius r is cut from a larger solid sphere of radius 2r as shown in the figure. The ratio of moment of inertia of the smaller sphere to that of the rest part of the sphere about y-axis is. Now y-axis is basically one of the diameters, right? So this question I should do, you should think about first the moment of inertia of the bigger sphere, then moment of inertia about the axis y, then moment of inertia of the smaller sphere about axis y. And then to find out moment of inertia of this sphere when the smaller sphere has been removed from it is nothing but moment of inertia of the bigger sphere minus moment of inertia of the smaller sphere. First of all, you should remember what is the formula for moment of inertia of a sphere. This is 2 by 5 m r square about a diameter. So this question uses two concepts. Number one, moment of inertia, By definition, then parallel axis theorem is also used. Then I is equal to ICM plus M d square. So what I am supposed to do is, first of all, what is moment of mass of the smaller sphere? Let me put it as m dash. This is equal to m by 8 because the radius of the bigger sphere was 2r and radius of the smaller sphere is smaller. So you can calculate that mass of the smaller sphere is m by 8 because mass is proportional to r cube. Okay. So what is moment of inertia of the smaller sphere about y-axis? Let me put it as I dash. This is equal to 2 by 5 m dash r square plus m dash r square. This is using parallel axis theorem because moment of inertia about this axis is ICM, I dash CM. Okay, so this is 2 by 5 m dash r square and distance between the two axes is r. So this comes out to be 7 by 5 m dash r square and m dash is m by 8 r square. So this is 7 by 40 m r square. And the moment of inertia of the original sphere was I, that was equal to 2 by 5 m. No, the radius was 2r square. So this is equal to 2 square is 4, 4 to the 8, 8 by 5 m r square. So in the question we have to find out ratio of moment of inertia of smaller sphere to that of the rest part. The rest part, the moment of inertia of rest part is equal to I minus I dash, and this comes out to be 8 by 5 minus 7 by 40 mr square. If you further simplify it, this will be 64 minus 7 by 40. LCM लेके आप कर सकते हैं इसको solve, and this is 57 by 40 mr square. And now you want what is has been asked? It is the ratio of moment of inertia smaller part to that of the rest. The smaller part was 7 by 40 and rest part is 57 by 40. So the answer is 7 by 57. So the correct answer is first is the correct answer. Okay. So you have to remember two things. Number one, moment of inertia of a sphere about a diameter. Then you have to remember parallel axis theorem. And the third is moment of inertia of the remaining part is moment of inertia of the original minus moment of inertia of the sphere about the same axis, right? Which moment of inertia of the sphere which has been removed about the same axis. Okay. Next, if you look up the question number 37, it says an electron, mass in charge given, moving with the speed of this, is injected into a magnetic field of magnitude this, perpendicular to its direction of motion. That means suppose this is magnetic field and electron is injected perpendicular. You wish to apply uniform electric field together with the magnetic field so that electron does not deflect from its path. Now this is a question of crossed electric and magnetic field. Now, crossed electric and magnetic field, it is possible that electron does not deflect from its path. You know that this is possible. This is possible when force due to magnetic field QVB is equal to Q into E, or Q gets cancelled. So condition is E and B should be perpendicular. E and B should be perpendicular. This is the condition for crossed magnetic field when the electron does not deflect from its path. This you have to remember. And second is the magnitude. So we are interested in the finding the magnitude of E, right? You are given magnitude of B. And from here you can see in a cross magnetic field, an electron enters a region of electric field with the value of B into V. Magnitude should be equal to B into V. Then the electron will not deflect from its path. So B is how much? 9 into 10 to the power minus 4 Tesla, and V is C is 3 into 10 C by 100. So this gets 9 3s are 27 into 10 to the power of minus, this is 2, and this is minus 4 minus 6, and this is 8. So this will be 2. And electric field is Newton per Coulomb, or it can also be volt per meter. SI unit you have to take care. So the answer is 27 into 10 to the power 2 volt per meter. But remember two things. Only magnitude is not enough. This magnitude is here and here, but E should be perpendicular to B. So the correct answer is 4. Okay. Next, if you look up question number 38, now electric field in a plane electromagnetic wave is given, and you want what is the expression for magnetic field. Remember two things. Number one, E and B are perpendicular. E and B are perpendicular. Number two, E and B are in phase. In phase. So these are the only things, because in each case the wave is propagating in the same direction, right? In all each of the four expressions. Otherwise, you also have to check if E there is a plus sign over here, then in B also there has to be a plus sign. Now, electric field is along the Z direction. Electric field is along Z direction. Therefore, and wave is propagating along X direction. So, magnetic field should be along the Y direction. This is first and foremost thing. Because E along Z, wave along X, therefore B should be along Y direction. Then also you should remember E by B is equal to C, where C is velocity of light, or B is equal to E upon C. So here magnitude of E naught is 60, so B naught will be 60 divided by 3 into 10 to the power 8. So this will be 20 into 10 to the power minus 8, or 2 into 10 to the power minus 8. So one thing is the magnitude, this is 2 into 10 to the power minus 8 plus 1 over here. So this is 2 into 10 to the power minus 7. So you can see 2 into 10 to the power minus 7 Tesla is here and here. But then B should be along the Y direction, and this third is the correct answer, because here B is magnitude is 2 into 10 to the power minus 7 Tesla, and wave is the magnetic field is along the Y direction. Although here also magnitude is same, but here B you can see is along the X direction, but B should be, E and B should be perpendicular. So the correct answer is third. So this is also moderate question. Next, if you look up question number 39, a body weighs 49 Newton on the surface of Earth. Gravitational force experienced by the body due to Earth at a height equal to 1/3 of radius of the Earth from its surface is. अब आपको वेट सरफेस पे दिया गया है, सरफेस पे दिया गया है. सरफेस पर जो वेट होता है वो क्या होता है? मास इनटू एक्सेलरेशन ड्यू टू ग्रेविटी ऑन द सरफेस. और वेट आपको एट ए हाइट पूछा गया है, तो दिस विल बी मास इनटू एक्सेलरेशन ड्यू टू ग्रेविटी एट ए हाइट h. तो अगर आपको दोनों का आपको चाहिए वेट एट ए हाइट h, दिस इज इक्वल टू just divide by weight at surface This is m gh divided by m g naught. So basically weight at the height h is equal to gh divided by g naught into weight at the surface. ये आपको ध्यान रखना है, ठीक है? Now weight at the surface is 48 and now you have to find gh by g naught. अब gh का फॉर्मूला आप ध्यान रखें, gh because आप देख रहे हैं कि जो यहाँ पर हाइट है that is comparable to the radius of the earth, so you have to find out, write down the right formula. This is equal to m g naught is acceleration due to gravity on surface, divided by 1 plus, and there is no m because we are finding gh. So gh is g naught divided by h upon r square. So here r, h is r by 3, so this is g naught divided by 1 plus 1 by 3 square, and this comes out to be g naught divided by 4 by 3 square. So 3 will go in the numerator. So this will be 9 g naught divided by 16. You can solve it, g naught divided by 4 by 3 square. So this comes out to be 9 g naught by 16. So just put up. So gh by g naught is 9 by 16. 9 by 16 into 48. So this is equal to 27. So weight on at a height h equal to 1/3 radius of the earth will be 9 by 16 times weight on the surface, and this comes out to be 27 Newton. Now look up, an unpolarized light traveling in air is incident on a medium of refractive index 1.73. Mu is equal to tan IP, 1.73. Brewster's angle. The light is incident at Brewster's angle. That is the most thing. Now, both reflected and transmitted light are perfectly polarized. Absolutely wrong. Brewster's law says reflected light is completely polarized, right? And the refracted light is partially polarized. So out of this, first of all, first is rejected, second is rejected, third one is, so here we need not even go for what the law says. The only thing is when the light is incident on a surface at Brewster's angle of incidence, then reflected light is completely polarized. So the correct answer is third.